Welcome. In this video I'm going to show you how you can obtain phi, an effect size measure for a goodness of fit test, using R. I'm using the Jupyter Lab with an R kernel, or at least I'm going to, um, and it has an R kernel of R version 4.3, and it has only the basic packages that usually come with R installed. The code should also work in, for example, RStudio. Now, this is an effect size measure for a goodness of fit test, provided you have a chi-square value. It then actually divides it by the maximum possible chi-square value and takes the square root out of that. If you want, you can actually convert this to Cohen's W using this formula. And I'm mentioning that because then you could use the rules of thumb for Cohen's W if you like to use those. To show you how this can be obtained, I need some example data. I'll be using the General Social Survey data from 2012, adjusted for some example purposes. I actually don't need all of its data, I just need one nominal field, so I'm going to be using as a nominal field the MAR1 data, which is the marital status. The table shows the counts, so I store those under FI from frequencies. And for example, 79 people indicated that they are separated. Now I have a separate video where I show you that you can actually get this quite quickly with my own library, but in this video I'm not going to use any libraries. I'm just going to use the formula itself. That looks perhaps a little bit daunting for some, but this is just a chi-square value. The n is the sample size, that's the easiest one to get. We can just sum those frequencies we had earlier. 1 divided over the minimum expected count minus 1. So let's first get that sample size in. Then I need to know how many categories there are. So in this case I can just use length. And then I need the expected proportions. Now in this case I'm just going to assume that each category was equally likely. So I'm going to repeat rep 1 over k, and I'm going to repeat that k times. So these are my expected proportions. Now in this case, for the minimum expected proportion is of course 0.2 because they're all the same. But if you had different ones, you could use, for example, min, and we can still use that to just select one of them. The minimum expected proportion is 0.2. Now, finally, that formula, we need the chi-square value. That's the last piece of the puzzle. I'll be using this formula. It's for a Pearson chi-square statistic. If you want to use a different test, I have separate videos on all kinds of different tests, but this is the most commonly used one, I think. It takes the observed proportion minus the expected proportion. So we take the observed proportion, so the observed count divided over the total count. We subtract the expected proportion and we square those results. Then we divide all of that by the expected proportions and sum all of those up. So we do this for each category basically, and then sum all of it up. Eventually we still need to multiply it with n, the sample size, so that's being done over here. And that gives us our chi-square value. We can now fill out this formula because we actually have all that we need. So we can say phi is the chi-square value divided over n times 1 over that PE minus 1, and we take the square root, which is the same as raising it to the power of a half. And that should give us 0.40. If you like, you can now convert this to Cohen W and use those rules of thumb. But I hope this video was helpful, and thank you for watching.